So, I mean, we could do whatever. If there's something you haven't understood, I don't care how far, if chapter 1, section 1.1, I didn't get this. All right, bring it up now. It's if there's something you didn't get, at least 8 other people didn't get it, but 7 of them are not here. So you need to, yes?
I have a question on 12.5, number 68.
68?
Yeah.
Okay.
So for C, how would I do the equation?
We're in 12.5, right?
Yeah.
68
Yeah.
or 69?
68.
All right, 68 for me is if there are 15 data points in a set of data, what's the number of degrees of freedom? So I don't. Are we talking about? So that one, for some reason, for me, it's 69. But that's right. That's the one that's number of driver deaths per 100,000, right?
Yeah.
Yes.
It's for the individual born in the United States in a certain year.
All right. So what's C say? Calculate the line of best fit.
It says calculate the least squares line.
Yeah. So that's the line of best fit. That's the other name for the line of best fit. So we do that in the calculator.
Yeah.
Yep.
Yeah. So why is it? It's just y. So it's just put the equation form with y equals a plus bx.
Yeah. So they like the a plus bx. So no matter what, what's the form of the line? Mx plus b.
Yeah.
I don't care what you call m and b. They mean the slope of the y-intercept. So they say put it in slope-intercept form, which is exactly how we get it from the calculator. Yes? No? So I don't care how you get the slope of the y-intercept. Bam! Mx plus b. And that's the form they wanted it. They just put the x at the end, so they're just weird. Right? They just want it in slope-intercept form. That's what they want, which is the way the calculator gives it to us. Cool. I like it.
Can we do number 5?
Yeah, so the 5A, some people have some trouble with that because when you put the information into your calculator, where are the weights?
L2.
L2. So when you do 1 var stats, you better tell it L2. Right?
Okay.
I don't want to get the 1 var stats for L1. I want the mile. So when you're making your confidence interval, number 1, are you going to use T or Z?
T.
Why?
It's a sample.
Yeah, good. I love it. Bam. Together, you're good. It's normal because I say so, and it's a sample standard deviation that we're getting. I have to use a t-score. I like it. So you're going to use this dude here to create the confidence interval. So when I ask you, make a confidence interval, it's got to be one of these 3, because those are the only ones that make an interval, plus or minus. So if you're in the middle, for some reason, when people do hypothesis tests, they throw a confidence interval in the middle. I'm like, what? Those are 2 separate questions, right? So if you're doing a confidence interval in the middle of a hypothesis test, stop, erase that. No, right? You don't need that. Is that right? I mean, some of you guys are like, of course I wouldn't do that shit. Okay, good. But I get too many people do that. I'm like, no, this doesn't, I'm not asking for a confidence interval. Is that good enough right there? Is that all right? So then you have to get your own X bar and S and go from there. I like it. Yes?
Are they going to be the questions like, what is the z-score and what is the standard deviation?
I could, yeah. You know I'm going to ask you either what's a z-score tell you, or what would a z-score of 2.39 tell you. I still have less than half getting it right, so I just stopped trying to keep track. Yes, right? I mean, there's only one answer to that. You can't tell me an area because the z-score didn't tell you that. The chart did. And I didn't tell you it was normal, so you couldn't even know if you could use the chart. A z-score by itself tells you what? Beautiful. The number of standard deviations from the mean to the data point. So if I say z is 0.17, you would say that data point is 0.17 standard deviations from the mean. In conversation, we can say steps, but don't put steps on the test. Write out, I just like standard deviation starts with the same letters as steps, and they actually make sense together. But you say standard deviation so that I know you realize what steps are, right? Yes?
What's the prove it's a valid probability distribution?
Oh, yeah. What two things do you have to check?
It has to be between 0 and 1.
What does? What does?
X.
Not x, right? X could be 5, could be 18 billion. What things have to be between 0 and 1? Probabilities.
Yeah.
Right? The probabilities all have to be between 0 and 1. And the second thing is they have to add up to 1, or at least close to it. Yes, maybe. Are you guys all right? You're like, no, dude. Finals are next week. You got to sit down. You think you're funny. Shut up.
Could you do number 1? Or like something from number 1?
Oh, all right. So number 1, if I were you, we did plenty of time on this kind of problem. I mean, what kind of problem is number 1? Don't tell me coffee problem. It's about coffee, but what kind of problem is it? Probability. What kind of probability? Because I tell you, what do I tell you it is? It's normal. I give you a mean and a standard deviation, and I ask you for the probability the price is above or below something, right?
Oh, yeah.
So what kind of problem is that? Can you draw the picture?
Yeah.
Shade in the area I want. That's your standard z-score problem, right? So if I were you, I'd find those and you can knock those out. Because the thing, sometimes you guys get in the mindset of certain problems, and then when you hit that one, your brain just goes, I'm like, no, you know how to do those. Draw the picture, shade it in, make a z-score, look it up. We know how to do those. So if I were you, I'd find those, get those done. Right, so if you're somebody that has to go 1, 2, 3 on the test, get out of that mindset. Think, I want to find these, find all of them, do them, and then, all right, let's go to these kind of problems. Find all of them, do them, or whatever works. Find one that makes sense and do it. Build up a little confidence. Okay, so everybody's got all this business? Yes? So, if I had a normal distribution with a mean of 12 and a standard deviation of 1.9, and I want to know the probability that something is greater than, what do you got, Jeff? Greater than 11. All right, so I tell you it's normal. I give you a mean and a standard deviation. I ask you a probability. That's your z-score. Look it up on the chart kind of problem. So, of course, when I draw this, what's going to go in the middle?
12.
12?
Oh, yeah.
I had all kinds of stuff happen. Where's 11?
Underneath.
I love those of you that just sort of put 11 wherever. It's on there. It's supposed to help you. Because now when I shade it in, which way am I going to shade it?
That way.
Probably the way the arrow's pointing. Yeah? All right, let's all just. So there's two things. That's a greater than. Bigger is up. And it's pointing that way, right? So that's beautiful. You can't beat that shit. If the variable's on this side, you shade the way this is pointing. That's true for algebra, true for here, true for all the time. I like it. So I want this area. So is it going to be more or less than 50%? More, yeah, because it starts down there and it includes this whole half plus some shit, right? So if I get an answer less than 0.5, I know I made a mistake. If I get a negative answer, holy shit, do not circle a negative answer for a probability. I get really worried, right? So what do I do now? Yeah, I gotta make 11 a z-score so then I can look it up because I got a sheet of answers for a normal curve. I got the sheet of answers. I just have to know where to look. So make it a z-score, I know where to look. So how do I make 11 into a z-score? Yeah, my 0.11 minus the mean divided by 1.9. Whatever that is. I think it's 0.507. I don't know, making shit up. No? Nobody's gonna help? All right, shit. So negative 0.53? Okay. And then you look that up in the chart. I don't think I brought any for myself. I'm so nice to myself. What do you guys give when you look that up in the chart? Negative 0.53. .02, what?
981.
Point 2981. 2981?
Yeah.
All right. All right, 2981, I'm gonna trust you guys. And then that's not the answer, right? Because I was nice to myself and I shaded where I wanted. I was also nice to myself, put the number I found below what I looked up. So a lot of this just depends on you being nice to yourself when you set this up. So yeah, you're right. I'm sorry. 1 minus this, 0.7019. I don't know if anybody does a shortcut, but it doesn't matter. It doesn't really save you that much time. You guys all right with that? Please. Those are the kind of problems you have to get to and knock them out. We did so many of this in so many different ways. You want to find this problem and make sure you don't screw it up because that should be bread and butter. Now, I think the second part of this problem, I do this. So the second part I say, what if we take a sample of 11, really, Jeff? Yeah, no, let's make it 15 data points, blah, blah, blah. What's the probability that the sample mean is more than 11?
Oh, you have to use the sample form?
The standard deviation of the sample means, yeah. Which means, what do I do? What do I do?
Use central limit theorem.
Yes, beautiful. Central limit theorem. Chicken, lettuce, tomato. So you got, this is not good anymore. Because that is the standard deviation for individual data points. I need the one for groups of 15. So it was 1.9. Now I divide by
12. Square root. Yeah, square root.
square root of 15. 15 is n. Yes? Okay. Some guys are still putting decimal numbers in there. That doesn't make any sense. Go get 7.8 people. I don't want to do that. Right? I need you for a, no, I just need part of you for a chop. And then whatever the hell that is, I don't know. What is that going to be? I think it comes out to like 0.5 almost. I don't know, roughly. So maybe point, I don't know. I'm going to step there, 0.5 about.
0.49.
Ah, shit, I suck. What is it, 0.49?
0.57.
So 491? Okay. You guys with me so far? I mean, so you know there's going to be a problem like this where I give you normally distributed thing, and I ask you a question about a probability, and then I say, what if we take a sample of blah? Okay, you got to change the standard deviation, right? Crazy ass Jeff always asks you a similar question to what I just asked you. Let me see if you guys get this. When I take a sample, will the new picture of sample means be skinnier or fatter? Bless you. Did the standard deviation get bigger or smaller? Smaller. So will the new distribution be skinnier or fatter? Skinnier. So the distribution for that will actually look like that. So is there more stuff or less stuff back here? Less, so there's going to be more. So our answer should be bigger than this, because when I take a sample, the sample means tend to be closer to the real mean. So there's less shit over here, there should be more shit over there. My answer should be bigger than this. Like it. Really set myself up now. Let's see what happens. So if I make a z-score, I can draw my picture again. 11, no, Jeff, what was it? 12, 11, blah, 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 blah. Make a z-score. What's it going to be now? My data minus the mean divided by? 491. So some of you guys do this work and then you don't use it. That really kind of freaks me out. You change it and then you're like, ah, screw that shit. Let me use the old one. I don't understand that. 4 times, so negative 2.1.
2.04.
2.04?
Yeah.
Oh man, it's just getting nice in here. You guys with me? And then you looked it up on the chart, get the area, do 1 minus again. All the steps are the same. I just had to use the correct spread. Couldn't use the one they gave me because that was for individuals. Same exact work, right? Once I change that, it's the same work. So you look that up and you do 1 minus. So that's basically 1A and 1B, or 1 and 1, 2, I guess, on the practice final. Yes?
What about 1C? Like, did you just find the z-score for that one?
Oh! So what is that problem dealing with? Z-scores or coffee prices? In general. That problem I gave you? It's talking about coffee. So your answer better end up being about coffee price, right? Or coffee cost. Does it make sense? So I'm not going to stop with the Z. That's when I have to use that formula I almost forgot. Yeah, you got to convert it back into what's called a raw score. In this case, a coffee cost. Yeah, so be really careful. P95 is not 95% confidence or some shit. What's P95 mean? It's a little better than P90. Yeah, no. 0.95 where?
Below?
Below. And then when you look that up in the chart, you'll see a very familiar, yeah, you'll see the little asterisk dude, right? You don't have to, but anybody know for a 90% confidence interval, what's the z-score I use? Yeah, and why does that make sense? This is all extra shit, okay? I'm sorry. I can't stop myself for some reason. How much is here? 5%? So how much is here? 5%. So this would be like a 90% confidence interval. That's why that z-score is the same number. But it's not a 90%. Anyway, if you don't quite understand what I just said, erase it. But it's kind of neat. So now I want to use this formula. Now that I know what the z is, I can put in the mean and the standard deviation. Because the answer is that many steps above the mean. I don't know if you guys remember, but that formula is the answer to what does the z-score tell you? The z-score is the number of these away from this to that. The number of standard deviations above the mean to the, or away from the mean to the data point. It's crazy. Crazy. Yes?
On number 3, part E, it says, what is P x greater than 3? So do you just
Oh,
add,
part B.
do you just add together all of the 4, 5, 6, and 7?
You could, sure.
Or just
Or 1 minus 3s. Yeah. Some of you guys go a little bit wild with your 1 minus. You just start doing 1 minus everywhere. I don't know if you're hedging your bets. Somewhere it's going to be the right thing to do. But make sure it makes sense. Yes?
Can you do number 3D? Because I don't understand, how do you look at the chart and then make your net and then...
No. You don't look at the chart first. No. You make your net first.
Okay.
Yeah, what I'm going to do, I'm going to catch fish. Am I going to jump in the lake and then put my net together? No, I'm going to put my net together. Then I'm going to throw it out. So what do you get for the mean? What was this? 3D.
The mean is 5.77.
Sounds familiar. Yeah. What'd you get for the standard deviation?
I didn't find it.
Well, shit. We can't make our net without that. What'd you get? Good, that's right. So we have a standard deviation of 1.455. So I want to go make a net that's 1 standard deviation wide on each, right? So just take 1 step up, 1 step down. So if I add 1.455 to this, I get like 7.2 or whatever, right? And if I subtract, everybody with me so far, right? Add 1 and subtract 1. If I subtract 1, I get 4.2 some business, I don't know. Or is it 4.3? You can do it, Jeff. Blah, blah, blah. Why am I not too concerned about the decimals right here? Because all my data points are whole numbers. So if I just go one place, I can see what they hit, what they get. What did I catch in my net? Did I catch the 4s? Did I catch the 4s? No, damn it. And they're the yummiest ones. What did I catch? 5, 6, 7. Well, if I caught all the 5s, what percentage just by itself did I catch already? If I caught all the 5s. What percentage did I catch? I tell you exactly what it is. 12% so far. What else did I catch? Oh, the 6s and the 7s. So what total percent did I catch? Add those up. Does that make sense? If I caught all the 5s, I caught 12%. Oh, I also caught the 6s and 7s. Okay, let me add that up and see what total percentage I caught, because P of X is a percentage. Is that all right?
So you look in the x P of x column, not the P of x?
So I see what data points I caught from the X. You with me? And then the question says, well, what percentage of the data did you catch? Well, what percentage are 5s? 12%. What percentage are 6s? 13? What percentage are 7s? So what total percent did I catch? Yeah, so what? 75%. Right? You guys with me? It's not 0.05, it's 0.50, right? Oh yeah, so do you guys remember what percentage should be within 1 standard deviation for a normal curve? 60. You guys forgot, okay, 68%. Another way to answer that question is looking at the distribution. Where should the highest point be for a normal curve? If you draw a normal curve, what's the highest point?
Wait,
I gotta take it, Neil. Sorry, Abby, I'm not. I just love that. Where's the highest point? At the top.
yeah.
But where's the top? At the highest point, Chuck. No.
At the,
In the
at the,
middle, right? Yes, for a normal curve, the highest point's in the middle. Where's the highest point in this chart? Is it in the middle? No.
Nope.
Which one's got the most?
4.
What is happening right now?
Where are you?
Dude,
There are 2.
help me, God. Okay. What percentage are threes? 11. 11% are threes. 14% are fours, 12% are fives, 13% are sixes. What percentage are sevens? 50. So if I made a histogram, where would the tallest bar be? At the end. Is that normal? No, done. There's another way to answer the question. If you forgot, it's supposed to be 68% within 1, and we got how much? 75%. So that right there doesn't look normal, but I can see there ain't no way it's going to look like this. It's going to look like rat, right? Or from your perspective, rat.
It has to be exactly 68.
No.
It could be above.
Because remember, we're using stuff very often that's approximately normal. I like it. So there are tests that go deeper into what that should be, but we didn't quite get there. It's only stats 1. Yes?
No question on 6.
Okay.
Like, what would be the claim that it says the average has now changed, like, and
Well, no. Careful. It has now changed. It says has now changed. Yeah, so they think that the mean is, I think you just said it, not equal to. Yeah. Whatever it was, 1.43.
So the whole is gonna be not equal, right?
No, the ho's always got to have the equal sign. And not equal to is not an equals. The opposite of not equal to is equal to. So that's going to be what the null is.
So the claim is the mean is not.
Yeah. Mean is not equal to because we think it's changed. Did I? Let me see. No, that's right. I think that was okay. Yeah, buddy, you did it. Yay, Jeff. Let's see what time it is. Gonna give you the key here in a little bit. Not quite yet. All right, now it's getting chilly. It's crazy. We're running an experiment on you guys. And me, apparently.
Show you better people there than hotter.
Dude, yes.
Alright, so for 6 again, like, what's gonna be the number you use for the claim, like, the number on the right?
What do they think it's changed from? What's the very first sentence say? Historically, it's taken them for 1.43 hours, and then immediately I say this group thinks it's changed, so changed from that 1.43. We think it's not equal to 1.43 anymore. Yeah. It's a good thing it's 1.43 because you only get 2 hours total. Yes.
The 68%, that's the Tuesday deviation?
1.
Oh,
1 is 68, 2 is 95, 3 is 99.7. That's as much as I know.
Also for number 7, so on that problem, like the confidence of P within 3, they've changed to a decimal, right?
No. Somebody did this. There was that one problem on the test where it was like number of texts,
Yeah,
right? Or, oh, you did it. You're not alone. I said to be within 10 texts, and people made it into 0.10. It's not 10%. That's when you change it, because 10% is not the number I'm working with. 0.1 would be the number. But if I say 10 texts, I'm dealing with 10. 0.1 text would be like, you put a letter and you send, oh shit. That's 1/10 of what I wanted to say. But I mean, so it's 10. It's a number. Only if it's a percentage, you got to change it to a decimal, because that's the real number it is.
So because on a lot of the practices like that you gave us, it was like 0.03, like
Because that problem was about percentages. I want to be within 3%.
Right.
This is not 3%. This is just within 3, whatever it was. Oh yeah, so within 3. I don't even tell you what it is. Oh, did I bring those? I think some of you guys need the chi-square chart too. Yes?
Yeah, another chart.
So if nobody's asking anything, the floor is yours. You can ask whatever you want to.
Can you like do a problem similar to 10?
10?
Yeah.
So 10 is a hypothesis test, so we got those 5 steps. But this is a percentage one, so this is where you have to get p hat, that kind of business, right? So if I said, I think percentage of people who watch dog shows is less than 22%, right? No idea what dog shows came from. And I talked to 148 people, and oh shit, Jeff, why'd you make this? And 27 of them say yes. Let's see what happened here. Let's see if I did good. Yeah? Okay, so he's like, you're doing fine, Jeff. Those are all numbers. Good job. All right. Test the claim. Claim using alpha equal to 0.05. Right. So what is the claim? So do it really mathish. P less than 0.22, big guess, right? Not mu, it's not about means. The hypothesis will only ever have population symbols, because I would never make a claim about a sample I can see, right? You're like, good job, buddy, you can see it, you make a claim about it, wow. And I claim that I brought tea today, oh, that's amazing. Which one is that going to be? The high, because it doesn't have a